Okay, so today I will be recording on how to solve an ellipse problem. So, introduction of ellipse. First, what is ellipse? An ellipse is a closed oval-shaped curve where the sum of the distance from any point on the curve to fixed points, the foci, is constant. Okay, next. So, why do you think ellipse is important and we need to learn it. We need to learn about ellipses to see how math connects to real life. They appear in things like orbits, tunnels, and designs. Studying them also improves our problem solving and prepares us for higher maths and sciences. So, in simple, ellipse not only helps us in other things but also helps us in our future lives. Not occasionally, but it still does help us. Okay, next, here goes my problem. So this is my problem. A small planet moves around the sun in an elliptical orbit. The sun is located at one focus point of the ellipse. So in heads up, my sun or the ellipse is already given. So the sun is 0, 0. Here are some examples and questions. First, this is the problem. What are the lengths of the major and minor axes of the orbit? Second, what are the coordinates of the foci where one of them is the position of the sun? What Third, what is the distance between the two foci? And fourth, sketch or describe the shape of the orbit, labeling the center, vertices, and foci. Okay, so first, I'll help you solve the lengths of major and minor axes. So in getting the a squared, or the first thing that you need to get is um, here. This denominator is dominant to the other, meaning it's much bigger. So this will be your a squared. 25 is your a squared as given, and your b squared, of course, is 16. So that's the squared. What will you do is to equivalent it to a. 25, the square root of 25 is equal to a equal to 5. Since that's already the square root, we're going to move on to letter b. B squared, the square root of 16, is equal to 4. In getting the major axis length, it's gonna be a formula. 2 times a, which a is 5. So 2 times a, 2 times 5 is equal to 10. In minor axis, it's pretty much the same, but with different number and letter. 2 times b, which is b is 4, so it's 2 times 4 is equal to 8. So our final answers are the length of major and minor axis of the orbit are major axis length 10 units and minor axis length 8 units. Okay, next. What are the coordinates of the foci where one of them is in the position of the sun? So, to get the foci, we have a simple and easy formula. First, F1, C, with the a while ago we talked about how to get the a squared, b squared, and their square roots. Now we will get the c squared to solve for foci. So a squared is 25 since it's a given in our past number. B squared is also 16, which is also given. So what we're gonna do is 25 minus 16 is equal to 9. C squared is equal to 9. Now square root of c squared is 3. So what we are going to do is, since f1 is once letter c, our letter c is 3. Since c squared, the square root of c squared is number 3. So f1 is 3 and 0. And f2 is finding negative c. If you might ask, why is it negative? Because it is um, counteractive to one another. Even though it is not a negative, you still need to put negative. So the answer is at negative 3. This is a typo. Negative 3 and 0. Okay, number 4. What is the distance between the two foci? So to get the distance between the two foci, you can this is the easiest um, formula of them all. Since the two foci are commendable at predictable, meaning they co- they have the same length between each other. So what you're going to do is 2 times c, which we know c in this equation is number 3. So 2 times c is 6, or 2 times 3. Okay, for the last part. Sketch or describe the shape of an orbit, labeling the center, vertices, and the foci. Since the center, which I told you earlier, is 0, 0, since the sun is at the center of it all, and the vertices we solved earlier, since the co-vertices now are pretty much the same as the vertices, I will still show you how they can be solved in a mathematical form. But first, I want you to see the graph that I made. Since the sun is at the center, we call it the center. And the focus here, and the focus here is where we solved a while ago. The foci. The foci there is the focus. And if you may not see the major and minor axes, but in solving the vertices, I may not include it here, but in solving the vertices, you need to um, do a and 0. So basically, in my past discussion, a is equal to 5. So the vertices is 5 and 0. And the other one is negative 5 and 0, as it is shown right here. And in co-vertices, 0 will be the first term because in B1 it will be 0 and B. And what is B in my past discussion is equal to 4. So it's 0 and 4. And transverse and then opposite, negative 0 and negative 4. So this is the graph. Since everything is in there, it becomes an oblong shape, meaning an ellipse. So next is my reflection. What is the importance of ellipse? The importance of an ellipse lies in its applications in astronomy, physics, engineering, and medicine. It is the shape of the planetary orbits used in medical devices like lithotrippers and appears in optics and agriculture, such as whispering galleries. Additionally, an ellipse is how a circle appears when viewed from an angle. And additionally, my teacher said that everything that we study in pre-calculus may not help us occasionally in the future, but it may help us in other ways that we'd imagine. So that's all. Thank you for listening.